where the bright name negodi man. All right, good morning and welcome to Master Talker online class. In today's video, we'll be talking about the thin lens equation. In our previous video, we talked about drawing uh, a ray diagram when an image is placed in front of a lens, whether concave or convex. You can watch the video, the link is on the description. Okay, now I want to talk about the lens formula. Once you know the lens formula, you have already known the mirror formula. Okay, I told you that a concave mirror and a convex lens has the same properties, and the convex mirror has the same properties with the concave lens. So solving them are just the same thing, the same diagram, the same solution, the same everything. Okay, just know that they are opposite each other. Concave mirror goes to convex lens, and convex mirror goes to concave lens. All right. So now let us consider a concave mirror. I have a concave mirror that is like this. This is a concave mirror. Sorry, a convex lens. Sorry, we're not talking about mirror. Okay, you know that a concave mirror is same thing as a convex lens in solution, like in diagram, not in real life, but the properties are the same. All right. So now let's have this thing to be a convex lens. Some people draw it like this, like they make it complete, but I just want to have one part of it. And then let us have that this place is the center. This is the center of a curvature. All right. Then you need to know that for a concave, okay, let's have a concave here, a convex here, and then have a concave here. I want to show you something. I have a concave here. Let's say that here is the center. Okay, center of curvature C. Now, let's have that the focus, this is the focus F. Let's have that here is the focus F. Okay, and then let's call it F1, and here is a 2F1. Okay, and there is F as well, and then 2F2, something like this, like I taught you in the previous video. Now, you should know that for a convex, you know that a convex lens is a converging lens. If they don't want to call it convex lens, they'll call it what? A converging lens. For a converging lens, you should know that what? That the focus of a converging the focal length of a converging lens must be positive. Anything greater than 0 must be positive. So the focal length F of a convex lens, please, the focal length of a convex lens must always be positive. And then the focal length of a concave lens must always be what? Negative. That is less than 0. So it must always be what? Negative. So whenever they gave you an equation or a question, and you now notice that the focus there, the focal length there is negative, then you should know that they are talking about what? A diverging lens. And a diverging lens is a concave lens. Okay, now if they give you a question and you notice that the focal length is positive, then that means that that lens is a converging lens, and the converging lens is what? Is a convex lens. That's the first thing you need to note. Now the next thing you need to note is that that the radius is from here to here. Okay, let's say here is the radius of the circle. This is the radius. This F2, 2F2 is the radius. This 2F2 is what? Is the radius. This 2F2 is the radius. All right. So you should note, another thing you should note, for both of them, they are the same. So the first thing we need to note is that for a convex lens, that my F must be what? Must be greater than 0, or you say that my F is what? Is positive. Okay. Then for here, we have that our F must be less than 0, or we say that our F is what? Is negative. Okay. Now the second thing we need to note is that the radius of the lens is always half of the focal length. Okay, the radius is half of the focal length, or you say that, sorry, the focal length is half of the radius, or the radius is equal to what? 2 times the focal length. Sorry, the radius is 2 times the focal length, or you say that the focal length is half of the radius. Okay, so if they give you the radius then you now know that what. So if the radius is in negative as well, it shows that what, that they are talking about what, this man. Okay, so note that again. So I now, the second one here is that what, that the focal length is equal to what, half of the radius. Okay, or you say that what, the radius is what, 2 times the focal length. So the third thing you need to know that if the radius now, if the radius is equally greater than 0 or positive, then we are talking about what, a convex. Okay, the same thing here. If the radius is less than 0, or you say that the radius is what, is negative, then we are talking about a concave. Okay, now number 4. Number 4 thing you need to know is that okay, now you should know that that when the image, okay, let's talk about the object. Now you should know that what, that the object distance, okay, or let's talk about the image formed. Now you should know that if the image is formed at the right hand side, all right, then you should know that what, that image must be greater than 0. Okay, whenever the image formed, the image distance, let me call it di. Okay, let's say that the image distance is a positive number. If the image distance is a positive number, or we say that the image distance, I want to be using this as image distance, okay, is a positive number, then you should know that it is formed at the right hand side, because my right is positive while my left is negative. So that means it is formed at, well, then the image is at the right, then the image is at the right. Okay, the same thing is applicable here. 4. The same thing is as applicable. Okay, so now number 5, you should know that if the image height, okay, let's go again. If the image distance is now a negative number, you know that your left is always negative, even in your real line. If this is your real line and here is 0, this side is positive and this side is negative. So if the distance of the image formed, okay, is where, is at the right of this center, is at the right. If it's at the right, then it is positive. If it's at the left, it's going to be negative. So if it is less than 0, then you should know that it is at the left. Okay, it is less than 0. Less than 0 means that it is what? It is negative. Okay, if it is negative, then you should know that the image is formed at the left, then the image is at the left. The same thing is applicable here. All right, then the next thing you need to know for number 6 thing you need to know is that then let's talk about the object height and the image height. Okay, they say that when the object is facing upward, or the image, if the object height or the image height, okay, let's start with image. Now if the image height is positive, that is, the image height is positive, what happened? If the height of something is positive, that means that thing is facing upward. But if the height is negative, it's facing downward. So your up is positive, your down is negative. So if the image height is what? Is positive, then the what? The image is what? Is upright. Now, and you know that for a concave lens, if it is upright, then it will be virtual as well. It is virtual. Okay, now but if the height of the image is negative, then what happened? Then the image is inverted. And I told you in the previous video that if it is inverted image, then it's going to be a real image. Okay, the same thing is applicable here. The same thing. If the height is positive, then you are standing straight, upright. Okay, but if it is negative, then you are inverted. Now, another thing you need to know is that whenever the object is facing upward, then another thing you need to know. Let's go to the object. If the object height, the same thing, just so that it's the same thing. If the object height is positive, then it's equally upright. Okay, but most of the times we keep the object upright. Most of the times we keep the object upright. Then find out how the image is going to be formed. Okay, that is why I'm not interested in writing that one. So another thing you need to know is magnification. uh Permit me to clean the ones I've written before. So let me clean from here. So the next thing you need to know is the magnification, number 8. Now, if the magnification is less than 0, that is negative. Or you say that the magnification is negative. If the magnification is negative. Now, if the magnification is negative, it shows that what? It is the same thing with this man. That the image is going to be inverted. Okay? If the magnification is negative, then the image is going to be what? Inverted. Are you with me? Please note that, because these two, the magnification and the image height goes together. The magnification and the image height go together. Anything that happens to the magnification should happen to the image height. Just note that. So if the image height is negative, then the image is what? Is inverted. Is inverted. And if it is inverted, it's going to be real. So if it is negative, then the image is real and inverted. Real and inverted. Okay? Number 9. So if the magnification is now positive, okay, or you say positive like this, anyone you like, greater than 0 means positive. If it is positive, then you should know that what happened. Then the image is upright. Upright. And I told that if it is upright, then it is what? Virtual. In the previous video, we have learned that already. Okay? So now the next thing you need to know, and the final thing, we have just 10 things to know. Okay? The final thing we are going to know, the 10th thing we are going to know, is that it's the same thing here. Is that if the what? If the image height, okay, is greater than the object height, what happened? If the image form is greater than the object, what happened? That means the image is magnified. Okay? That means the image is big or magnified. So if the image height is greater than object height, then what happened? Then the image is magnified or big. Magnified. Okay? Or use the word big. So number 11 is the opposite. If the image height is now less than the object height, are you with me? Then what happened? Then the image is small or diminished. The image is what? Diminished. Okay? The image is what? Diminished. So if you know all these things now, it will now help us to do our calculation. So the calculation we are going to do now is, let's now write the equation that will help us in our calculation. Okay? And this equation goes, all these things I said is the same thing as a mirror. They are all the same thing with mirror. Just that the one I wrote for convex here should go to the concave mirror. The one I wrote for concave here should go to the convex mirror. So if you have not watched my video on plane mirror, this one will help you as well. Okay? What I just said here will help you. So let us do this. The formula remains the same. You should know that 1 over f is equal to what? 1 over what? The distance, object distance, plus 1 over what? Image distance. But some people use some textbook will use 1 over f is equal to 1 over u plus 1 over v, something like that. Okay? How do you use to remember it? I used to remember it by saying UVIO in a clockwise direction. UVIO. What does it mean? That object distance is the same thing as u, and image distance is the same thing as v. Okay? That is how I used to remember it. UVIO. So that is what? That the image distance, that the object distance means what? My u. And then, but in your calculation, no need using this thing. It will confuse, not even me. It will confuse you. Always use your d and this. It will help you. And they are the same thing. You can use anything to represent whatever you want. Okay? Now, This is the first thing you need to know. Okay. Now, the next thing you need to know is magnification. Magnification. Magnification is simply, in magnification, we are talking about magnifying the image. So the image should be at the numerator. So magnification is simply negative the distance of the image over what? The distance of the object. That is magnification. Negative what? Image distance to the image object distance. Or you simply say image height without any negative. Image height over what? The object height. So once you know these two formulas, you are done. Any other question, you can solve it. Once you know this thing, and then you know these principles I gave you here, then you are very good to go. So let us do something now. Let us solve some problems to help us illustrate what I just said. Okay. All right. The first question I'm going to solve here. The first question I'm going to solve here said that a converging lens. Okay. Okay. Let's have. In fact, let me just have that. The first question. I don't want to write it. They gave us that our f is equal to 6 cm, comma, and our do is equal to 8 cm. You know that they can call this thing do, or they will say that it is u. I hope you know u. If they call it u, okay, let me use u, and then I say that that the height of the object is what? Is 2 cm. Now we have this thing. Once they give you your own in u, change it by yourself. Just write for me UVIO. UVIO. You must move in clockwise direction. You must move clockwise like this. You must move clockwise. Okay. So what does it mean? My u they gave me is the object distance. So I will say that my f is equal to positive 6 cm. What did I tell you? Once you have seen that your f is positive, then you should know that this is a converging lens or a convex lens. I told you that if x is positive, if f is positive, then it is converging or convex. But if it is negative, then it is what? Diverging or what? Concave. All right. That's the first thing you need to know. Now, which means they gave me our do, because u stands for this man, this one stands for this man. So they gave me uo as what? As 8 cm. Okay. And then my ho as what? 2 cm. Now let us calculate our things. Then we will now draw our diagram. The first thing we'll calculate, let's say that 1 over f is equal to what? 1 over, you can use your u and v if you like. You can say 1 over u plus 1 over v, no problem. Or you use the other one you know. Okay. Well, let me use this one since they call it u and v. So we'll have that what? 1 over 6 is equal to 1 over 8 plus 1 over v. Now the LCM of everybody is 6 times 8 times that v. So if I multiply everybody by the LCM, I'm going to have, that is 48. The LCM is simply 48v, to make it easier for me. Okay. Or you just find your LCM the normal way. So, or let me just collect like terms. This one will go here to miss this. So I have that 1 over v is equal to what? This one coming here is what? 1 over 6 minus 1 over 8. So what do I have now? My v, sorry. Let me just do it like, or in fact, to clear denominator, that's the easiest way. The first thing to do is to clear the denominator. How do you clear the denominator? Multiply it by the product of everything, or the LCM, anyone you like. But instead of finding LCM, just multiply by the product of everybody here. So the product of everybody is here is what? 48v times 1 over 6, okay, is equal to 48v times 1 over 8 plus 48v times 1 over v, okay. So you will now see that v take care of v. This into this will give you 6, and this into this will give you 8. So I have that 8v is equal to 6v plus what? 48. So this one can come here. So 8v minus 6v is equal to what? 48. So therefore 2v is equal to 48, which shows that my v will now be what? Permit me to finish it here. My v will now be what? 48 divided by 2, which is what? 24, right? 24 cm. So don't forget what is your v. Your V is what we call the image distance. The image distance. So therefore, my image distance is my what? 24 cm. So always write all of them in case, depending on the way they call it in the exam. Okay? So the next thing you need to calculate, we have gotten the, now let's get the magnification. Don't forget that magnification, please always use, don't use this first. Always use this one first to get your magnification. My magnification, always use the distance. Don't use the height. The magnification is what, because why am I using the distance? I'm using the distance because if you're using a mirror, okay, or if you're using a lens, maybe a camera, to view something from a distance, you will see how big is that thing is, or how small it is. Depends on the distance of that image to the lens you are using. If I'm using a camera to capture you now, if you are very far, I have to enlarge it. You understand? So the distance where you stand depends on how big or how small you are going to be, which is the magnification. So the magnification is what? Minus d of I. I must be up because I'm talking about the image first before the object. So minus this over this. So therefore, my magnification will now be minus my this is what? 24, minus 24 over my d of O. My d of O is what? 8. So what do we have? That is 24 by 8. You have 3. So I'm having minus 3 as my what? My magnification. What did I tell you whenever the magnification is negative? If the magnification is negative, that means this image is inverted. And if it is inverted, it is real. Okay? Very, very simple. You see that this thing is very simple. So now, this thing will now help us to show us the height of the image, because I know that my magnification normally is equal to what? The height of the image over what? The height of the object. So I have that minus 3 is equal to what? The height of the image I have all over what? 2. So if I cross multiply, I'm going to have that the height of this image will now be minus 3 times 2, which is what? Minus 6 cm. Okay? And I told you that what? If the height of the image is negative, it means you are upside down. And then if you compare this now, compare the two of them, you see that the height of the object is 2, while the height of the image is 6. What does it mean? It is magnified. It is big, because my height, the height of this image, is greater than the height of the object. So this image is magnified. So it depends on what they ask you to find. They say, where is this image located? We'll find out. Then I say, how tall is this image? This image is 6 cm tall, but inverted. I hope you know. Then I say, what is the magnification? The magnification is 3. Okay? The magnification is 3, or you say negative 3. Negative shows how the image is, but the magnification is 3. Just know that. So the next thing is, the next say, draw a ray diagram to illustrate this. That one is even the easiest, which will help us to know where this image is. So I have my horizontal line. That is my what is it called? If you can remember again, what do we call that line? Remember the name. So I have that, since this is a converging, I'm going to have a convex lens. This is my convex lens. Okay. Now let me now say that this my foci is here. Let me say that here is my 6 cm, the foci. This is my foci F, which is 6 cm. Now, then I say that the object distance, where is this object placed? The object distance is 8. Okay? They gave us that the object distance is 8. If the object distance is 8, does it mean that it is closer to the lens, or far away from the lens? It should be far away from the lens. So which means I am the one standing here. I'm that object standing here. So here is 2 cm. So that from here to here is the 8. 2 plus this to give you 8. So this is me standing here now. Okay? If I'm standing here, now let us see how to draw it. If you can remember what I told you about the drawing, that we use two things. Here should be another 6 cm. We are going to have 2 foci, another 6 cm. Okay? You have to measure it, please. Measure it with your ruler so that you don't make mistake. Now, the first principle of drawing this thing, like I taught you before, is that any line that is parallel to this this horizontal line, which is called what do we call it? Let me remember the name of that line. they say that a ray of line that is parallel to the principal axis. Thank you. Any line that is parallel to the principal axis must pass through the focus. It must pass through this focus. Okay, that's the first principle. Now the second principle said that what, anyone that passes through the center of curvature move on the same straight line. So this man is going to move like this. Don't mind my own drawing, I don't have a ruler. Okay, so make your own straight. Now you see that this image is formed here. This is where the image is, and then we know that the image is inverted. So you are going to see now, if you look at this now, you will see that this object is smaller than this image. That's exactly what we got. We got that the image height they gave us, sorry, the object size they gave us is 2, but the image height we calculated is what, is 6. Very, very correct. So the question should be, where do you think this image is formed? Where do you think this image is formed? This image is formed behind the, okay, behind where is it formed? Oh, okay, it is formed behind the lens. It is formed behind the lens. Okay, so that is the diagram. That is the diagram. They say that where is the image formed? So now you know that if here is 6, we have another one that is going to, you have to measure this thing. Try to measure it. We have another one that will give us 2f. That is the radius. It is formed behind the radius. The image is formed behind the radius. So because here is another 6 cm. Okay, the image is formed behind the radius. So that is that. Any other thing? Nothing again. So let us solve another question to help us understand better. You know that the more calculation you solve is the more you understand it. Okay, now the second question I'm going to solve now said that, the second one said that, okay, they said that your f is 6, your u now is now 4. They decided to reduce my u as 4, and then my h is 2 cm. Now let us now calculate everything we have calculated before. So first of all, what do you see? For the fact solution, for the fact that my f is positive 6 cm, what does it mean? Number one is that it is a converging lens because it is positive, and a converging lens is what? A convex lens. That's where you start from, and thank God you know the properties of a converging. So we did not talk about the properties of that image. Oh, we have already talked about it. One, it is what? Real and inverted. Secondly, it is magnified. Thirdly, it is formed behind or beyond the radius. Okay, it is formed behind the radius. All right, so what do we do? So they gave us this, and they gave us our u. You now write your UVIO, UVIO, and UVIO shows that what? My u represents my DO. So my DO they gave me is 4, and they gave my HO as 2. Okay, now if I have all these things, what do I do? Let us first of all calculate the V. Let's calculate our V. I know that 1 over F is equal to what? 1 over U plus 1 over V. Okay, so what do we have now? We now have that 1 over 6 is equal to what? 1 over V, sorry, 1 over 4 plus 1 over V. So what do we have now? We will now have that multiply everybody by 6 times 4 times V, which will give you what? 24V, right? So multiply everybody by 24V, multiply each by 24V. So to have 24V in bracket of 1 over 6 is equal to 24V in bracket of 1 over 4 is equal, sorry, plus 24V in bracket of 1 over V. So what do we do now? This into this will give you 4. This into this will give you 6. This into this. So what do we have? This is 6V is equal to what? 6 plus, sorry, 6, what am I saying? 4V. 4V is equal to what? 6V plus 24. So this one coming here, I'm going to have that 4V minus 6V is equal to 24. So therefore, minus 2V is equal to what? 24. And then my V will now be what? 24 divided by minus 2. So what do we have? We have minus 12. So what does it mean? So this means that my V, if you have your UVIO in clockwise direction. So my V means D of I. My V is D of I, which is equal to what? Minus 24. Oh, we didn't even say it before. Okay, we should say it now. Let me remind you, in the previous one we solved, our di we got was positive, and if it is positive, it means it is at the right hand side, and when we drew it, we discovered that it was at the right hand side. But this one now, my di I got here is negative, and negative means what? The distance of the image is negative, so the image is going to be at the left. The image will not be formed at the right. So let us see what is going to happen. Okay, let us calculate our magnification. Okay, to calculate our magnification, I know that magnification is what? Always use your D minus di over what? Do, which is what? Minus into minus 24 all over what? Your do. Your do is 4, so which is going to give me 20, that is 6 cm. Now what did I tell you? I told that if the magnification is positive, what does it mean? The image is standing upright, and if image is standing upright, what does it mean? It is a virtual image. I told you any image that is upright is what? Is virtual image. So is there any other thing to calculate? Nothing to calculate. They say we should what? How tall is it? Okay, they say how tall is the image? The image is where is it? Where did we get the image height? Okay, we have not gotten the image height, but I know that my magnification is equal to what? The image height over what? The object height. I told you everything about image should be at the up first. So I have that 6 is equal to what? The image height I'm looking for all over the object height, which is 2. If I cross multiply, I have that my image height is now 6 times 2, which is what? 12 cm. So you see that they say that how tall is it? It is 12 cm tall. Okay, they now say where is the image formed? The image, if you look at this is negative. The image is formed at the left hand side. Okay, it could be behind the object. It could be behind the object. Okay, let us even see if it is really behind the object. Where is my object distance? The object distance is 4. Okay, and the image distance is minus 24. So I think it is even behind it. Yes, the image is formed behind this man. So what else again? And for the fact that this thing, I hope you know that whenever whenever you have that the magnification is positive, I told you that the image is going to be standing upright and virtual. And this is what? This is a property of what? Of a, what's it called? Of a convex lens. You know that if you go closer to a concave lens, if you go closer, the more you go closer to a convex lens, you will start getting the properties of a concave lens. You understand? I told you in the previous video, so go and watch it. So now let us draw the diagram to see how this image is going to look like. I have my principal axis, and I have that this is my center of curvature. Don't forget that the radius is what? Twice your focus. So let me say, where is the focal? The focal length is what? Is 6. So let me say that here is 6, and what? Here is 6. Okay. Now what happened? A man now stand 4. The distance this man is standing is 4. So this man is somewhere here. This man is somewhere here. So if here is 4 cm, okay, I'm making it look as if they are equal. So let me say that he is standing somewhere here. So here will now be 2 cm, here will now be 4 cm, because the total length from here to here is 6 cm. I hope you know that. Okay. Now you can use your ruler to measure it, but I just want to sketch. I just want to sketch. Okay. Now let us take the normal procedure. Okay. A line that is parallel to the principal axis passes through the foci. We know this one now. Now the second one is that the one that passes through the center of curvature moves on a straight line. Now having this thing now, you see that no image is formed here, but if we try to take it backward, we will not see where the image is now formed. Let's keep this thing like this. Let's assume that the thing formed somewhere. Let's say it formed somewhere here. Okay. You will now see that this image is at the back here, and if it is at the back, it is upright. Okay. You see, so everything is done. the image is formed behind the object. Like I told you before, it is formed behind the object, and the distance was what? Minus 24. So negative 24 from this lens. Okay. What again? The height of the object, the height of the image, is 12. And it is what? Magnified, because it is bigger than this. I thought that if the image height is greater than the object height, then it is magnified. Okay, so it is magnified, and we got that the magnification is what? 6. That is 6 times the normal object height. So this is 2, and then the other one was 12. You see, that is the magnification. So what else? So every other thing, see that this is very easy to solve. So let us now solve more calculations, because more calculation will lead us to more understanding. More calculation leads to more understanding. Okay, the next calculation I'm going to solve, let's solve some question for concave. We have solved for convex. You know that convex is converging, while concave is what? Diverging. So let's talk about diverging lens or a concave lens. So let's have, they gave us that our F is equal to what? Minus 4 cm, and our D of O, which is our U. They gave us that our U is what? 12, and our H of O, the height of the object, is the same 2 cm. Okay, so let us now answer this thing. Now the first thing you should note, since our F is negative, what does it mean? It means, hello, please help me check. What's the time? It's 6. Okay, so let's have, having this thing now, what do we do? Because I have negative for our F, it means that this is what? A diverging lens. And if it's a diverging lens, it is what? A concave lens. That's the first thing you need to know. Okay, now the next thing we need to calculate is we know that solution, our formula does not change. That 1 over F is equal to 1 over U plus 1 over V. Okay, so what does it mean? We have that 1 over minus 4 is equal to 1 over 12 plus 1 over V. So therefore, multiply everybody by, see that obviously the LCM here is 12. But if you don't want to use 12, just say 4 times 6 times V. Okay, but somebody can just use, obviously, that it is 12V, because this can divide this. This is found this side of this, so it's obviously 12V. So I can multiply everybody by 12V, multiply, or if you multiply by the product of two of them, you will still get the same answer. Multiply by 12V. So I have that what? 12V in bracket of minus 1 over 4 is equal to 12V in bracket of minus 1 over 12 plus 12V in bracket of 1 over V. So this take care of this, and this take care of this, and this into this is 3. So I have 3 times this will give you minus 3V is equal to what? V plus 12. So what do we have? This one going here, have minus 3V minus V is equal to 12. So what do we have now? My minus 4V is equal to 12. Then my V will now be 12 divided by minus 4, which is what? Minus 3. Now, what does it mean? Now, this thing means that they gave me, don't forget your UVIO. So my U means the object distance. So the distance of this object is 12 cm. So the distance of the image, I just calculated it to be what? Minus 3 cm. What did I tell you? Whenever the distance of the image is minus 3, what does it mean? It is formed at the left-hand side. That's the first thing you need to know. It is formed at the left-hand side. So let us calculate the magnification. I know that magnification is what? D of negative D of I all over D of O, which is minus into minus 3 all over what? All over 12. So what do we have now? My M is what? 1 over 4. Now, I told you that if the magnification is less than, is less than 1, you know it is positive. Hope you know it's positive. And if it is positive, first of all, it's positive. And I told you, if it is positive, what happened? That it is upright. First of all, it is upright. And if it is upright, what happened? Yeah, it is virtual. It is upright and virtual, which is what? The properties of a concave lens. You see, this thing does not lie. This thing does not lie. So, but if it is greater than 1, if it is greater than 1, then it means that that image is small. That image is reduced. If it is, sorry, if it is less than 1, sorry, if it is less than 1, then it is reduced. Okay, it is reduced. So let us check if it is true, if it is really reduced. Now, the image is reduced, but let us check if it is true. From here, I know that my magnification is equal to what? H of I over what? H of O. So I have that this one is 1 over 4 is equal to what? H of I that I'm looking for, all over H of O they gave me is 2. So if I cross multiply, I'm going to have that my H of I is going to what? 2 over 4, which is what? 1 over 2. You see? 1 over 2. This is 0.5, but this one is 2, which shows that what? This image is small. Is small. I told you that. Okay. So note that if my M is what? Is less than 1, then the image is small. So note that. Note that I didn't tell you, it's part of what you need to know. I didn't tell you in the other one. So this calculation has helped me to know that. So let us draw it and see what happened. First of all, I know that this is going to be a concave lens. Why? Because my F is negative. So it's a concave lens. It's a concave lens. Don't forget the properties of drawing a concave lens. First of all, the foci is 4. Here is 4. And then somewhere here is 4 again. Okay? And then since it is 4, at the left, it is negative. So it's at the left. Then I know that they say that the distance of this object is 12. If the distance of this object is 12, that means that this object is standing maybe somewhere here. Let's assume that it's somewhere here. Okay? This object is somewhere here. Then what happened? Let us now draw our this thing. And I told you that in drawing your concave, you should know that what? That the line that is parallel to the principal axis appears to be coming from what? Appears to be coming from the foci. It appears to be coming from the foci. So it's supposed to go somehow like this. It appears to be coming from the foci. So it continues that way. My board is very small, so it continues that way. So, and the one that moves to the center goes parallel as well. It goes the same straight line. It doesn't bend. So this is where they met. So this image is formed here. So this image is formed here, upright. So notice that, first of all, the distance of this object, the distance of the what? Of the image is negative. If it is negative, it is formed at the left. Correct. It is formed at the left. Now, this one is smaller than this one. Like I told you, that if the magnification is less than 1, then the image is smaller than the object. Correct. What else? What else did I tell you? I told you that if it is positive, if the magnification is greater than 0, that is means positive. It means that it is what? It is erect and virtual. You see? So any other thing you want to know, they are all there for you to know. So let's solve, I think, the last question in this particular video. Let's solve the last question in this particular video, then we are done. The last question for this particular video, they gave us that our F, question number 4, they gave us that our F is minus 6 cm, okay, and they gave us that our DO is 3 and DO is U. I hope you know. And then they gave us our HO as 2, okay. So you write your UVIO in the clockwise direction. So it means the solution, I know that my 1 over F is equal to 1 over U plus 1 over V. 1 over V. So my U they gave me is something as DO. My U is something as DO, which is what? Which is 3 that they gave me. So I have that 1 over minus 6 is equal to, for the fact that it is negative, what is it? Concave lens. Don't forget. And or if this is a mirror, it's going to be what? Convex mirror. Please note that everything about concave lens is the same thing as what? Convex plane mirror. Please note that. That's why I told that everything I'm doing here will help you to understand a mirror. Just swap it. Okay. So I have that here is what? 1 over, what is my U? Is the DO, which is 3 plus 1 over V. All right. So obviously, I'm multiplying everybody by 6V. So multiply by 6v. To have that 6v in bracket of minus 1 over 6 is equal to 6v in bracket of 1 over 3 is plus 6v in bracket of 1 over v. So I am left with minus v here. I am left with 2v here, and I'm left with 6 here. So what do we do? Minus v minus 2v is equal to 6. So minus 3v is equal to 6. Then my v, I hope you know that v is the same thing as di. So di is equal to what? 6 divided by minus 3, which is minus 2. Okay? Now, what does it mean? The distance di is minus 2. Minus 2 shows that it is formed at the left. The distance of the image is equally at the left. That's one thing we have noticed. So, and then next thing we need to find is the magnification. I know that my magnification is negative d of I over what? D of O, which is negative what? Di. What's my d? Where is my di? Have I gotten di? Yes, my di is minus 2 all over my do. My do, where is my do? My do is 3. So I'm having that my answer is 2 over 3. 2 over 3 shows that 2 over 3 means it is positive. And if it is positive, then this image is standing upright. So if it is upright, then it is a virtual image. So that's what you need to know. Then another thing you need to know that this 2 over 3 is less than 1. And what I tell you, if it is less than 1, then what happened? Then what did I tell you about being less than 1? I cannot remember. So if you can remember go back to the previous video, you will remember. Okay, but just know this one. This one is very obvious that it is less than, it is positive, and being positive means that it is upright and virtual. So let us now calculate the height of the object. Okay, I thought that if it is less than 1, then the image is small. Yes, the image is small. It's not magnified. It is small or diminished. I use the word diminished. Yes, that's what I told you. I just remembered. So, but we know that even if you don't want to know it from here, you calculating the height of the image will help you to know, even if you don't want to know it from here. So my HM is equal to what? HI over HO. So I have that my 2 over 3 is equal to HI over my HO is 2. So HI is now, this time this, 4 over 3. And 4 over 3 will give you 4 divided by 3. 4 divided by 3 will give you 1.33. 1.33. Now, you see that my HI is less than my HO. So if the image, the height of the image is less than the height of the object, then it is small, it is diminished. Okay? So, and that is a property of what? A convex, a concave lens. And I thought that anywhere you like, stand on the concave lens. The properties are always the same. Anyhow you want to do it, anywhere you want to stand, the properties are always the same. So let us now draw the diagram and see what happened. Let me draw it like this. This is the center. It is a concave. It is a concave lens. This is my center. If they say we should calculate the radius, what do? If you want to calculate the radius, don't forget that my radius is what? 2f, which is what? 2 times minus 6, which is what? Minus 12 cm. In case they say you should calculate the radius of the curvature, okay, they can ask you that. Some examiner asks that. So from here, what do we do? Let us draw it. First of all, the focal length is 6 and 6. Okay, so and then the object distance, the distance of the object is 3. So do I move closer or further? I should move closer. So it is 3 here. This is where I am standing. I am the object. This is where I am standing. And don't forget the principle. The principle says that the one that is parallel to this man appears to be coming from the focus. So if it appears to be coming from the focus, then I have this. But the one that is parallel, the one that passes through the center, moves on a straight line and does not bend. You see that obviously this image is formed here. And what happened? The image is smaller than the object. Obviously, the image is at the left because we got negative. Don't forget, Because we got negative, it is at the left. What else again? It is upright. And if it is upright, it is what? A virtual image. I hope you understood this. Thank you very much for watching. Please don't forget to like, share, and subscribe. Love you.